Okay, we're going to take a look at the last lesson here in Unit 5-6. We're still looking at equations and algebraic modeling. And what we're going to do here is we are going to look at how you create an algebraic model and then how you solve an algebraic model for an unknown variable. So by the end of these two topics, what you should be able to do is use expressions and equations to model problems, and then turn around and solve these problems by solving the equations. So this is putting together all of the stuff that we've done up until now in Unit 5-6, solving equations and the algebraic model. So let's take a look at what you've got at the top of the page. Is you've got sort of a list of steps you should follow each time you see one of these word problems. First of all, identify what you are being asked to find in this problem. What are they asking you what is the whole point of this problem? What are they asking you to have at the end of it? Okay. Then usually you have two things that you're trying to find. We're going to choose a variable to represent one of them. This is our let statement we just talked about. We're going to let the variable represent one of these things that we are trying to find. The other thing that we're going to try to find, we're also going to express it in terms of that variable. To do this, we have to think about how these two things that we are trying to find are related. And then we have to combine these expressions into an equation. Now, these first four things are exactly what we were doing in that last lesson when we were doing that modeling. In each one of those ones, we did the first three of them, and then sometimes we could combine them together into an equation. All we're adding here in this lesson is we are solving our equation, and then we are writing a little sentence at the end where we sort of repeat what they were asking us to find and put it in nice terms. Okay? So let's try an example here. First question you've got on that page. The sum of two consecutive integers is 47. We want to find the integers. Okay, what are they asking us for in this question? What are we trying to find? A sum? Do they want us to find the sum? They want the actual integers. So we want to find the integers. Okay? So our answer at the very end should be basically two numbers. Okay. So let's do step one here. We have done step one. These are the two things that we were trying to find in the question, two numbers. And we know they have to be whole numbers because these are integers. Let's choose a variable to represent one of them. This will be our let statement. And in this case, we can just say let x be one integer. So x is going to represent one of these integers here. That's step two. Now, express the other thing that we're looking for in terms of the same variable. So if x is one integer, what is the other integer? Okay, how is it related to x? Well, if these things are consecutive, how do we get from one integer to the next? What do we have to add here? Heather, do you have a copy of this? Okay, good. All right. So if they're consecutive, they come one after another, like 4, 5, 6, 7. How do we go from one integer to the next consecutive integer, Emerson? We have to add 1. So what is the other integer going to be? If our first one is x, x plus 1. Okay. So if x is one integer, x plus 1 is the other integer, the sum of these two integers is 47. So what do we have to do with x and x plus 1? When you see that word sum, what operation are we thinking? Addition, subtraction, multiplication, or division? Sum means we're adding them. So if we take one integer, x, and we add the second integer, x plus 1, we are going to get 47. And that is step 4 there. We have combined our two expressions into an equation. So step 5 here, we want to solve this equation here. So first thing I'm going to do is I'm going to get rid of the brackets. X plus 1 equals 47. Now, what do I see here? X plus 1 equals 47. Well, how should I try to solve this? What should I look to do first on that left side? Sindela. Combine the like terms. So x plus x gives me, so I have 2x plus 1 equals 47. Now, how would I solve this next? I got 2x plus 1 equals 47. What should I do to try to get that x all alone, all by itself? I'm going to subtract the 1. So I'm going to subtract 1 from this side, and I'm going to subtract 1 from that side. And I got 2x equals 47 minus 1 is 46. Where do I go from here? 2x equals 46. How can I solve this? Remember, I want to get that x all by itself. Keep going. Divide both sides by 2. So 46 divided by 2 is going to give me 23. So I've got x equals 23. Now I go back to my original question here. What was I being asked to find? I was being asked to find two numbers. I've got one of them, x, which was my one number. My other integer was x plus 1. So if x is one of my numbers, the other one is x plus 1, or 23 plus 1 is 24. So those are the two things that I was trying to find. So now I wrap all of this up by saying 3 dots, which means therefore, the numbers are 23 and 24. Okay. So it asked me for two numbers in the original question. I want to make sure that I give them two numbers in this concluding statement here. All right, should we take a look at the next one here? Catherine is 2 years older than Christine. The sum of their ages is 16. How old is each girl? Okay, let's start with our let state. Oh, sorry. What are we trying to find in this question? What are they asking us for? Yeah. So how old is each girl is what we're being asked to find. So our answer should be the two ages, the ages of the two girls. So we're going to use our let statement here, and we're going to choose a variable to represent one of these two ages. So what do you think our let statement should be here? What do you think? Let's pick a girl and choose a variable to represent her age. Go ahead. Let K represent Catherine's age. Whoops, and I spelled Catherine wrong. Catherine's age. Let K represent Catherine's age. What's the other thing that we're looking for here? It's Christine's age, so we need an expression to represent Christine's age. So I've just written down here, blank is Christine's age. How are Christine's age and Catherine's age related to each other? Okay. Well, there are two ways. We're told that Catherine is 2 years older than Christine. So if K is Catherine's age and she is 2 years older than Christine, what does Christine's age have to be? Dante? K minus 2. Right, because Christine is younger. Okay, so her age has to be smaller. Good. Now we've got this other way that these two things are related. The sum of their ages is 16. So what can I do with this K and this K plus 2? What do you think, Liam? When you see that word sum, what operation do you think you have to do here? Addition. So we're going to take K, we're going to add K plus 2, and what does that have to add up to? 16. Here's our equation that we need to solve. This is very similar to the last one. Dante. Ah, thank you. So, yeah, make sure you copy these things down correctly from one line to the next. All right, so let's solve this thing here. We can collect our like terms. K plus K gives me 2K. I see that minus 2 there, so I can add 2 to both sides, doing opposite operations. And I'm just going to write down plus 2 underneath. Okay, so I'm doing the opposite of the operation I see. I'm doing the same thing to both sides. So that's going to give me 2K equals 18. Divide both sides by 2, and I get K equals 9. So, Catherine is 9 years old. How do I figure out how old Christine is? Well, K minus 2 is Christine's age. So if I do K minus 2, 9 minus 2 is 7. So those are the two things I was looking for, 2 ages. Therefore, I can say that Catherine is 9, Christine is 7. Is 7. If it asks me for 2 ages, I have to give them 2 ages in that final sentence there. Okay. Let's take a look at the next one here. The length of a rectangle is triple its width. The perimeter of the rectangle is 40 centimeters. What are the length and the width? Okay. Well, let's start with our let statement. Oh, wait. Before we even find that, what are we trying to find in this question? Heather, what are we trying to find? The length and the width. So what are the length and the width here? Okay, so we're going to choose a variable to represent one of them. Which one do you want to choose, Heather? Length or width? Okay, you could do length. I think it's going to be better to do width in this case because we are told the length is triple its width. So we're given length in terms of the width here. So we're going to use W for width. So if W is the width, what is the length going to be if the length is triple the width? Well, you see that word triple in there? What operation do you think of doing? Mesrit? Multiplication. So the length is going to be? Not 3L, but 3W, right. Okay. So we've got our two expressions here. Now we have to combine them together. We're told that the perimeter is 40 centimeters. So we need that formula for perimeter. How do we calculate perimeter of a rectangle? Let me think back here. What do you think, Stephanie? Okay, that would be a square. A length times width would be area. You're right, Stephanie, we want to add them all up, but we want to have the sides different, so it's got to involve length and width. Dante? Yeah, two widths and 2 lengths. Or we can just say width plus length plus width plus length. Okay, to follow Stephanie's example where we're just adding up the sides as we go around. Okay? Now, what do we know in this expression here? Well, we know that the perimeter itself is 40 centimeters. What is our width? We've just used W to be our width here. So I'm just going to keep that W there. What is our length? It's 3W. So I add on another width, and I replace this length with another 3W. And now we can solve. What am I going to do to solve this thing here? Isaac, what would you do to solve this? Would you do the right-hand side? It's not sure. Help him out, Emerson. What do you think? What can you do with the, what do you see about these terms on the right-hand side? Which means they are what kind of terms? So what can we do with like terms? We can always, let's add them all up. So 1 plus 3 plus 1 plus 3 is going to give me 8 W's. And now it's pretty easy to solve from here. We're just going to divide both sides by 8. And we get that W equals 5. So if W is 5, what is the length going to be? Three times 5, or 15. Okay, so back to the original question here. We're asked for the length and the width. So let's make our sentence at the very end here. Therefore, the length is, let's see, which one is our length? Oh, our length is 15 centimeters. Okay, we got to put in our units here at the very end. Comma, width is 5 centimeters. Okay? They gave us centimeters in the original question for our perimeter, so we got to work those centimeters into the final answer. Okay. So we set it up, we get our equation, and then we solve. Okay, last one here. This is the trickiest one. If you can do this kind of question, you can do anything in 5-6 here. Are we ready? Sort of. Maybe. Yes. Okay. Wait. Not quite. Almost. Well, you've got it in front of you. Take a second, read the question, and think about what you would do for your let statements. Okay. Jar contains 27 coins. All of them are dimes and quarters. There's a total of $5.55 in the jar. How many dimes are in the jar? All right. So first thing, step one. What are we being asked to find in this question? Number of dimes. Okay. So when we go to do our let statement, we want to choose a variable to represent the number of dimes. What should we choose? D. So let D be the number of dimes. Okay. Now, the learning guide suggests that to do this kind of question, we set up a little table. Okay. We're going to have 4 columns here. I'm going to call the first one the type of coin that we have here. So these are the 2 things that we have in this. So we've got dimes and we've got quarters. Second column, I'm going to call the number. That's for the number of each of these things, dimes and quarters that we have. Third column, I'm going to say the value of one of these things. And the last one, I'm going to say the total value of this. Okay? And we want to try to fill in as many of these little boxes in our table as we can. And I'm going to add another one down at the bottom here. I'm just going to put a big line across here, and I'm going to say the total. So for instance, the total number, or the total dollar value of all this stuff. So we're given that we have 27 coins. That's the total number of coins that we have. Okay? We're also told the total dollar value of all of these things, $5.55. Okay. Now, how many dimes do we have? We don't know. We've already let D be the number of dimes, so I'm going to put D in there for the number of dimes. If we have D dimes and 27 coins in total, how many quarters should we have? We don't know the number, but we can come up with an expression for it. Got 27 coins in this jar. D of them are dimes. All the other ones are quarters. What expression can we have here, Abby? 27 minus D. Everything else has got to be a quarter. You just take away the number of dimes, and that gives you the number of quarters. Our next column here, the value of one of these. Well, how much is a dime worth? 10 cents, or in dollars, we can write that as 0.10. Okay? And I'm going to use dollars because down here, when they gave us the total amount of money, they gave it to us in dollars. How much is a quarter worth? $0.25, or 25 cents. I'm going to do $0.25 because, again, they gave us everything in dollars. Now, if I have D dimes, each one of them is worth 0.01, how much are they worth in total? I just have to multiply this. D times 0.01 is 0.1 times D. If I've got 27 minus D quarters, each one of them is worth 0.25 cents. The total dollar value of all of those things is 0.25 times the number that I have, 27 minus D. This last column here gives me my equation. Okay? I know that if I take 0.1 D and I add it to 0.25 times 27 minus D, so the value of my dimes plus the value of my quarters, those have to add up to 555. So that's going to be the equation that we need to solve. 0.1 D plus 0.25 times 27 minus D equals 5.55. And now we need to solve. Okay. So I see those brackets in there. When I see those brackets, I know what's the first thing I want to do. I want to get rid of those brackets, okay, by using this distributive property. So I'm going to multiply that times that, and that times that. So I'm going to keep the 0.1 D out front. 0.25 times 27. Punch this into my calculator. I get 6.75. 0.25 times minus D minus 0.25 D. All of this is still equal to 5.5. Let's move this up a little bit here. What can I do next? Well, I look for like terms. I got a D here, I got a D here, I'm going to combine them together. So 1.1 minus 0.25. Punch this into my calculator. 0.1 minus 0.25, negative 0.15 D. Everything else stays the same. Okay. So negative 0.15 D plus 6.75 equals 5.55. I still want to get this D all by itself. So what do I have to do to get D all by itself here? What do you think, Aaron? I see something multiplied by the D. I see something added to it. What should I deal with first? This multiplication or this addition? So how do I get rid of that 6.75? What do I do to both sides of my equation? If I see addition, I do. And what am I going to subtract? 6.75. Excellent. So I'm going to subtract 6.75 from both sides. I keep that 1.5D, negative 1.5D. Punch this into my calculator. Let's see, 5.55 minus 6.75 is negative 1.2. Now what do I need to do? Still want to get d all by itself. Done. What am I going to divide by? Divide both sides by 0.15. Almost. If it's negative 0.15, I got to divide by negative 0.15 on both sides. Okay? And when I do this division, what do I get? Anybody got a calculator handy? Do this division. And while they're trying this on their calculator, think about this. The number that we get when we do this division, should this be a whole number? Should it be a fraction? Should it be a decimal? What do you think? Can we have like half a quarter or a third of a quarter or something like that? No. So we better get an integer or a whole number when we do this division. What did you get, Sandella? Did you do it? Positive 8. Yes. So we got a whole number. We got a positive whole number, which is good, because if we got a negative 8, we would have done something wrong, because you can't have negative 8 times or something like that. So d equals 8. Now, we go back to the original question. Do we need to find the number of quarters? No, we just need to know how many dimes there are. D represents the number of dimes, so we're done. There are 8 dimes. Okay? Nice concluding statement, and we are done.